morning. So I'm just here this morning to talk about some of the results of our monitoring over the last couple of years in both Northern Ireland and the Republic of Ireland. So as you know, artificial light sources attract insects, and the degree of attraction really depends on the spectral properties of the actual light source. So insects are attracted or sensitive to a broad range of colours. The colour sensitivity plays an important role in relation to navigation, feeding and mate selection for both flying and terrestrial insects. And degree of attraction greatly varies between the insect groups. So bats don't mind a few insects, so as a result, we like to know what is the result, the impacts of this attractive property of light on the insect population, and as a result, the bats. Now, RIDEL 2006 divided the different bat groups into different categories according to their behaviour around streetlights. So in relation to the 9 species of bats we have on the island of Ireland, the first category includes the Nicholas species, where we have the liveless bat, and the medium-sized fast-flying insect or flying species that exploits the insects around the actual street lamps. And then we have the small, fast but fast-flying manoeuvrable bats, such as Pipistrellus, that will exploit the insects around the actual light cone and sometimes within the light cone. And then it goes on to the more slow-flying species, such as the Myotis species and the Placotis, that are more vulnerable to predation and therefore are unlikely to actually exploit insects in and around light sources and may often actually avoid these open lit up areas. Now, we just literally looked at the data we collected from our monitoring schemes, and I'm just going to describe 2 of the monitoring schemes that we have in play. The first one is our Powerbase Path monitoring scheme. It's been running in the Republic of Ireland since 2003, and Northern Ireland joined us in 2006. These are literally driven transects. We have 30 kilometre squares that have been randomly selected across the island. We have 28 of these that are annually surveyed in the month of July and August by our volunteers. Within each 30 kilometre square, there are 1.6 kilometre transects. There are 15 of those. All of them are individually discrete transects with a minimum of 3.2 kilometres in between each transect. Our volunteers will drive these transects at 24 kilometres an hour, and any bats that are encountered are picked up on the Tranquility Transect time expenditure detectors and stored on mini discs or smartphone devices for analysis later. And of course, these provide us an ideal opportunity to actually look at the impact of street lighting along these driven transects. Now, our volunteers are encouraged to avoid large urban areas. So where they actually encounter streetlights tends to be either in villages or in the outskirts of some of the towns they're travelling through. The second monitoring scheme, is Dublin Bat Watery Survey. Basically, we follow the BCT methodology very strictly. So it's a walking transect, and our volunteers go out on a 1 kilometre transect, count Dublin's bat activities at 10 survey spots for 4 minutes per spot. But we do collect a range of data, including waterway characteristics, weather conditions, and we do collect additional data on the presence of lighting and different habitats that are located along the actual transect. Now, the Dublin has been running since 2006. It's an all-Ireland scheme. To date, we have 485 waterway sites covered across the island, surveyed at least for 1 year. We have lighting data for 71% of these sites. Now, it's a twofold process with regards to this particular scheme. In 2011, we asked the volunteers, is there lighting present or absent at each of your survey spots? No more. We did an analysis in that year with regards to that data. And then in 2012 and 2013, because we felt we needed a little more information, we asked them to start differentiating the colours of the light at each of their survey spots, and also was on the far side or the near side of their walking transect. So I'm going to go through those in 2 separate ways. So basically, the reason why we collect this data was literally there's an increased amount of aesthetic lighting of bridges in Ireland at the moment, and then an awful amount of waterways, walking sites are going in, which is great, but they are putting in a lot of lighting along these urban walkways, especially along our canals, the towpaths along the canals. So the analysis now, I don't do the car transit, so I better get the analysis right, otherwise Niamh will get back to me after she watches this video. So literally the car-based modelling data and the REM L model was actually undertaken at a level of 1.6 transects, with the dependent variables log transformed and expressed as passes per minute. Then the quadrilateral term was actually also included in the model, and this was in relation to the starting time of monitoring the transects in relation to time after sunset, because we felt this was important to actually have a temporal pattern of activity within the model to allow for the fact that the pipistrelles do have an increased amount of activity up until about 3 hours after sunset. The terms were fitted for a log transference number of each of the streetlight colours at each of the transects. And then to help visualise the actual results, the model actually created two scenarios. The number of back passes on transects where there was no streetlights, and the number of back passes at transects where there's a minimum of 20 street lamps of each of the three colours that we actually looked at. Now, in summary, as you can see, the majority of the driven transects did not have streetlights at all, and this is a reflection of the fact that we did do more rural or semi-urban areas for the actual driven transects. So out of all the transects that are driven, 418 had streetlights, 1,326 streetlights, a majority of which were your orange, followed by yellow, by white. Now, we didn't differentiate what type of lighting, we just asked volunteers to go by the colour. But in the majority of situations, these do reflect to low pressure sodium, high pressure sodium, or the mercury lights. There's not much LED street lighting brought into the rural areas in Ireland as of yet. Now, in relation to the common pipistrelle, we found no significant impact, positive or negative, on the actual number of bat passes for this species along the driven transect. But we feel that this may be something that's happening here, that there is probably a vegetation or a habitat influence on the activity more so than the actual street line, but something that we have to look into further. Again, it was the same for the soprano pipistrelles. There was no significant positive or negative impact on the number of bat passes according to different colour treatments compared to where there was no street lights. On the other hand, for Lyser's bats, there's very much a significant impact on the activity levels of Lyser's bats. And as you can see, there's this lovely increase, stepwise increase up from orange to yellow to white, which yellow and white lights having the greatest impact, where there's a lot more Lyser's bat activity around those particular lights. And indeed, the actual error bars don't overlap between the different treatments, even emphasising further the actual significance of this. Now, going on to the Daw-Bentons, because we're completely aware that the Daw-Bentons waterway sites, there's an awful lot of factors that could be influencing the activity along these waterways. So we used literally presence and absence at the spot level and put that into a general linear mixed model to actually, first of all, find out what of all the different variables are actually significantly impacting on the presence or absence of Daw-Bentons bats at each of the survey spots first, and then look into how does that impact in relation, or is there an influence in that still from street lighting on the Daw-Bentons activity. So I've just given you an array of different variables that we tested first, and this is from the 2011 results initially. At that point, we had 422 waterway sites surveyed, 31.5% of them had street lighting present along the actual waterways, with survey spots that are in the model, 10.7% of them had street lights around them. So the significant variables included such things as the width of the river, and as you can see, that was a positive impact. So in other words, the wider the river, the more likely you're going to encounter Daw-Bentons bats at your survey spot. Temperature was a quadratic positive relationship, so there was an optimum temperature for Daw-Bentons activity that was between 15 and 18 degrees. Either side of that, and the activity was less. Trees, of course, the presence of trees had a positive impact. Hedgerows unusually had a negative impact, but we considered that as more of a landscape issue. It is literally the reflection of the fact that where there's hedgerows, there's open agricultural fields, and that could be the reason why this is unusually a negative impact. Rainfall, of course, had a negative impact. Spot number was a quadratic impact. In other words, you've got your 1 kilometre transect, spot 1 and 2 at the start of transect. It's only 40 minutes after sunset. It's likely that bats haven't actually come onto the waterway yet. So there's a reduction in the number of passes that could be there at that point. While at the end of it, you could be going back to where your car is parked, it's more urban, so that's why there was always a lot more activity in the middle of the actual transit than on either end. And from this, we found that streetlights did have a negative impact when we took in all of these other variables as well. So, in the raw data first, you could see that there was a 15% less likely chance of dog bed and spots being present at the survey spot if there was lighting present. When it was adjusted and back transformed with all the different variables, there's still a 9% less likely chance of dog bed and spots being present. Now, with the 2013 results, we have all this lovely new data that our volunteers are wonderful at collecting. They start deciding what was the different colours present at the survey spot. So 162 waterway sites had lighting, and you see the different variations in the lighting that was present, and we had near and far side information in regards to this. So taking the whole lot from the start, we had a much greater database and a lot more data to play with. So again, still with the raw data, 11% less likely chance that dog bed and spots will be present if there's lighting, and when it's adjusted, it's a 5% less likely chance. But when we actually start looking at far side and near side, I've highlighted all these here. In the deep yellow, they're all significant results showing a negative impact of all three colours on the near side on the actual dog bed and spot activity. While this one is a little on the strange side, it's a slightly borderline positive impact of orange light being on the far side, but we think this is just a chance and something we have to look into a wee bit further. When I plotted this, you can see that for all the adjusted values, so this is back transformed values, all three lights had significantly less likelihood of bats being present if there was street lighting there. So for white lights, it's 12% less likelihood, yellow lights 15%, and orange 11.6%. Now, these are just pure colours. I can't say what type of lighting they are, can't say for sure, but in the majority of cases, these we do refer to your low sodium, pressure sodium, high pressure sodium, and your mercury vapour lights. So in summary, there's no evidence of the impact of roadside street lights, positive or negative, on commoners chronic pipistrelles. This does contrast elsewhere with other studies, but we think this may be related to a vegetation structure thing. As we showed with the dog bed and spot, when you bring in a lot more variables, you get a lot more information and more definitive answers. It may be something like that we need to do for the pipistrelles. While for the livelids, there's a definitely clear significant relationship between livelids activity and streetlights, more livelids activity around yellow and white lights. And this relationship is expected and has been reported before. For dog bentons, there's a negative impact from street lighting, and where survey spots are much less likely to have dog benton spots present. Lighting on the near side river has a greater impact on the activity recorded, and the further study we did in relation to colours has shown that there is a negative impact for all three light treatments that we recorded. Okay, thank you very much, and great.